Okay. Okay, good. Okay, so a few quick announcements. So today we will have office hour right after class until about, let me see, until 1 o'clock. All right, so today is from whatever at the end of the class until 1 o'clock will be office hour academic search. For tomorrow, that we will still have office hour. This will be available through Zoom, but physically I will be in academic search as well. So which means that you can actually come over. And the only trouble is still from 2 to 5. The only trouble we might have is because tomorrow is a holiday. They might lock down the building. So you might not be able to get in, just like you come in today. So we need a communication protocol. So maybe around I would say around 1:50, I will go downstairs to just open the door for you guys, or I don't want to use the trash bin. That's some student did that, use the trash bin to block the door, which is probably not a great idea. Yeah. Yes, I have the key. Yeah, definitely. I have the key to get in. Yeah. Yes. Yeah, I'm talking about 3 hours. So I miscalculated, but because we started at 10 o'clock, so that's why it's 1 o'clock. So sorry, 10 to 1, not 10 to 2, not 11 to 2, it's 10 to 1. Okay. All right. So so that's tomorrow. I think I will find a way to let you in. That's no problem because I will be inside already. And plus academic search has multiple doors. So sometimes we need to be creative to do that. But by the way, we need to do some way to be quicker. Probably you guys might want to just message me about my Facebook, maybe Facebook Messenger or some other way. Maybe I'll just write down the. Let me write down my phone number. So you can just text me. Hold on. I don't want to be recorded on YouTube. How do I actually make this up? I don't know how to make this up. Hold on. That's okay. At the end of the class, just what? Yeah, I can do that, but I don't want to do that right now. But at the end of the class, I will provide you my mobile number, and then you can actually contact me. Okay. Okay. Any other question? All right. So the focus right now, I will be focused on homework 5 right now. Okay, and homework 5 will be due very soon, and homework 6 and 7 will be work together with your final project as a group. So just like every year, homework 5, 6, I actually make the group project. So kind of have you guys work together as a group of 3 or 4, and also you can, based on that experience, extend it to your final project. Okay. So, so yes, please quickly form your group. I think I will put the sign up for you to submit a message probably before Thanksgiving that you must actually form a group to work on. You cannot work on this by yourself. It has to be at least 2 people, 2 to 4 people. Yeah. Tomorrow Zoom is still at 2. Yeah. Right. So I will assume that we did this like office hour on Zoom, so people coming in, but there are still maybe a few students in the room as well. Yeah, I will send it. Yes. Yes, we will be talking about the detail, but right now what you need to do, you need to get your group set up so you know who you will be working with, because it's a group not only for your whole final project, but also for your. Let me actually show you the picture. I was actually set up the final project just yesterday. So this is still in my home, but it will be actually in my in your. So you can see that I'll probably distribute this. I don't know how to distribute it. This is in my home. Tell you that I'm actually setting up 2 Raspberry Pi and then putting together. Pass around. People want to see. Yeah. So it's actually going to base on that, and basically I just play around your homework 4, homework 5 using JSON. So essentially what you'll be doing for your, it's a base, hardware and software base being installed. And then you will be develop some application. I would like you to try to do some innovation in this idea. Means that I'm giving you an environment, which as I described before, I don't know if you still remember, that is a computational environment to allow you to do some of the application that's actually very different from today's the internet connected world. Okay, so any other, yeah, you have a question? Yes, you probably have a 1 week to do the implementation. It will be enough, but the idea you should probably start talking right now. Doing the implementation. So the final project, typically the amount of code you need to write is not a lot, but you will get what I call a quick prototype to demonstrate the major idea. But that will be significant because you will be running on a real hardware. It's a different hardware that you will be running. And I will help you with that process as well. So you can, if you actually focus on that okay, so let me actually talk very briefly because I have a different session. I would like to talk about final project. So typically the way final project works is that you form your group. Then essentially for each of the group, I have a one-on-one session with them. So I usually use a Zoom, but I think this year what I'm going to use office hour to actually have you one-on-one. You have to sign up the time, come to my office hour. Each group probably give you half an hour. So in that case, I will actually clarify all the questions you haven't know the answer from my instructional video about final project. But the main purpose is to help you to converge your interests because you have 3 or 4 members, you're actually interested in different ideas. So you want to converge that. And after converge, my job, usually I can get it done by the first meeting is that to cut down the scope. Maybe you're dreaming this big. So I'm actually helping to cut down to something which is the first step to reach that dream. So I mean, to be honest, every single innovation developed, they have to have a big dream. In fact, I want you to have a really big dream, bigger than whatever those people in Silicon Valley has, much bigger than that they have. But then I'm going to cut down and say, well, realistically, what should be your first step to actually reach that. That's the process I hope you to go. Don't be limited yourself because you're afraid you're not knowing C++ well. That's definitely the last concern. But think about try to dream something big and then try to develop. That's what I want you to do. And so the first meeting, you kind of have a converged idea. Then you actually usually student will come to me for second or third meeting. The third meeting usually is like a pre-demo about what you have done. And this quarter, because we are actually physically here, so I'm actually want to arrange a room, a conference room, such that you guys can do a final demo, everybody going there. And then I will go there to go around to grade all of you. And then I'll probably invite some other faculty member who are ecs36b faculty member will go there to grade your homework as well, to actually at least know what you're doing. Yes? Yeah, it's not going to be the final day. We're not going to use that final. Wait a minute. Which day is the final day? You know? Yeah, I prefer not to use that day because you know what? Maybe that's a good idea. Let's do a Monday. Let's try to make sure that we finish on Monday. So we will be, we'll use that as a day for our final project demonstration grading. But I will find a different room. My worry is that I might not be able to find a room that's actually nicer. The classroom, yeah, this is actually okay, but okay, let me tell you that why I don't like this room, because the Raspberry Pi I'm going to set up is going to be somewhere different. So I want this two Raspberry Pi, they will not be able to talk to each other. If I'm going to put two Raspberry Pi in this room, they will be direct connect to each other. So I'm actually, let me plan that out to see if we can use academic search. With academic search, I have a perfect setup, a two room. One is the lab, one is the launch. So we can actually install a device such that they're further apart. Yeah.
So, I'm going to fly out that because all my finals are before that Monday and Tuesday. Are you going to plan anything after that?
No. Number one, I think that's a good point for you to raise. So if we do Monday as a final demonstration, you will be able to make it, right?
Yeah.
At the same time.
Well, that's the day of the final.
Yeah. Okay. We'll do that. We'll do that. Yeah. Yeah. Yeah.
Oh, is it Tuesday?
Yeah, whatever we're going to do that. I haven't checked the exact final day. Usually I don't worry about that until 2 hours before the final. Okay, usually. Because I'm an instructor, you're the student. I'm just I mean I'm on campus 24/7 pretty much, so it doesn't matter which day it is. Okay. All right, so we'll confirm that, settle the final schedule. So you will be, I mean, just be honest, this time is a lot easier to me that you guys are on campus, we can do this together. I mean, the past 2 quarters when I do this, I have to schedule 3 days because each group will just zoom in for half an hour to 1 hour. And I have probably bigger class than this one, you know, that I do until like a 1 a.m. or something. It is this time will be a lot easier because we're doing this on campus. Okay. All right. So so last time we finished the we finished the exceptional handling. I hope now you know some of the programming issue you need to worry about, why you need exceptional handling, and what is the C++ library that's doing exceptional handling. So one of the things you should realize right now is that in object-oriented programming, one of the objectives that people try to do is that everything needs to be an object. So exception is an object, and a class is an object, of course. That every facility, like JSON, is an object, and then RPC, JSON RPC is also an object. So essentially, in object-oriented paradigm, we try to make everything to be an object. So in order for you to connect the whole world with object-oriented, essentially object-oriented is help us to model the world. So we're actually interact with the world. Instead, we interact with the object. So when I first developed the idea of object-oriented system in 1987, we actually consider a person as an object. It's not like a person.cpp kind of object. It's like a you are the object. So usually at that time, if somebody say, oh, I'm working on the research, I'm not saying that you're working on any research. I say, well, I love anything that's object-oriented. So including people as well. So that's the model, because when a person using the keyboard or mouse interact with the computer, that is really a person, real person object interact with the computer in there. So in order for us to universally to take care of the concept of object-oriented programming, it's important to find a universal representation of objects. You can actually collaborate or interoperate between different type of object, including object represented by different language. So one of the idea that have this universal representation, which is at the current status for the past maybe at least 10 years or even more, is JSON. So JavaScript object notation became that universal representation. By the way, it was not JSON when I first learned object-oriented language in 1987. At that time, it's called XDR. XDR stands for representation of a general XDR. I forgot D probably just data. R is representation. So it was a different type of methodology and never took off really well. But the JSON really took off in the past, how many years? I don't know, more than a decade probably. So homework assignment number 5, sorry, is trying to push you to understand, to do the conversion, to both familiar with this new representation, which you already start to understand a little bit, but also how do you actually write the code to bridge the world into that universal? Because once you can go to that universal representation, you can do everything, connect that to another language or another platform. So essentially with JSON and with RPC, you will have the capability to truly implement a object-oriented system that's actually connect everything together. Okay, so that's the tool that you're learning. So this is 50% of this. I'm going to ask you to do this by yourself before you do the other part, which you work on the group. So this is the DUMJ. It's essentially how do I convert a C++ objects into a JSON object. So I'm giving you a set of objects. Some of this you're already familiar with. You should be familiar with core already. Person you should be familiar with. And now we'll introduce a few things like a post, message, comment, and reaction, which is essentially a very typical social media system, how they actually allow people to communicate. So the example that I gave last time was this. Where am I? Sorry. Yeah, this is an example. In fact, this is not only the example, this is the example that's included in the reference implementation that you actually should run it. Let me actually just pull it out very quickly. In the C++ code, I want to show you what it is. If you look at this, this basically has a message. This is basically a new person. He's actually create a new message. And this new message, I just say test message for homework assignment number 4, part 3, that was from last year. And then has a timestamp. And then I actually start to create a comments. Let me use Emacs. Emacs is probably easier for me to display this thing. A little bit bigger. You can see that this test driver is already provided for you. It's actually using the objects that's created, person object and message object, and then the time object is I call it this is a JSON value time that I create this class for us to manage time in this program. And then I have a comments, and you can look at now I can actually create the comment is here. The comment is over here that I actually create. Wait a minute, where's my comment? Yeah, comment is here. This is actually a comment that you created. Once you have the comments, then you essentially use this comment to create reaction. The reaction again has a person, has a time, has a reaction say love, and the reaction say happy. Okay, so essentially, if you correspond, this is a program that corresponds to a typical scenario. Sorry, it's not a complete post, but it corresponds to just one comment and the 2 reaction, as I show you. So you can see that here's a 1 action with 2 comments, with a person, with a timestamp, with 2 reaction. One says love, one says angry, or something like that. So this is a program representation about what I just shared on that. Okay, so I'm actually using this few classes to really create. Let me get back to what I have here. So you're given a bunch of class already. Those class represent the interaction, such as the post object, message object, comment, and reaction. What you need to do, the concept called DUMJ, is how do you be able to generate the JSON representation, which looks like this. This is the JSON representation. Too much. How do you actually represent a JSON representation looks like this? So you can convert from that C++ and then generate a JSON value object like this one. So essentially, this is the JSON representation of the whole post for testing both homework assignment number 5, homework assignment number 6. What kind of step-by-step to do that? Of course, there are 2 ways. You can actually convert this to the C++ object. That's called JDUM. That's actually you're going to do for homework assignment number 6. For homework assignment number 5, what we want you to do is first, how do you actually generate this once somebody actually already converted to the C++? If you finish both homework 5, homework 6, then you essentially know both direction how to do that. Then essentially you complete your capability to do a lot of things with this universal object representation. Okay, so this is what I showed you last time when I explained the JSON code, I said, well, you look at the reactions, and this is how you actually be able to extract the information from the reaction. But right now in the DUMJ, what we want to do is that, well, if I have already extracted information to the bottom part, how do I actually regenerate the part on the top? So on the top, you can see is a reactions array. It's a reactions array, which is representing individual reaction, but we actually add to that. So this one has only one reactions. So I'm going to show you now how to generate JSON that's actually contain an array of such object. So now I'm going to show you this code here. I'm going to reaction, I'm going to comment. First, let's actually look at the definition of comments. It's just a normal C++ code. It has this concept called the try component for the ID, which is a profile ID, post ID, and comment ID. There's three portions. Remember, I said there are three ID concatenate together with two hyphen. Those three, and then that comment has author. That comment has So my voice is out, right? Because the battery is out, I think. Okay, all right. Now it's better. Okay, so and then we have this person who made the comment, message, what is the content of the comment, and JV time represent the time when this comment was created. But this is the part I really want to focus right now, is the reactions. The reactions, you can see that it's a array in C++, everything is an object. So an array is an object. So one of the most popular representation of array in C++ is called vector. So let me show you the syntax. So basically a vector is under STD, means that it's a standardized class. So STD vector is representing a particular class. This class is called vector class. And the thing is that it's an array. So we want to say is what kind of array it is. So you need to provide some kind of data type. So in between the smaller sign and bigger than sign is what we call the type of the array. So essentially, if you read your code over here, this basically say it is an array of array of pointer to reaction. Okay, so the type is, reaction is a type, and then star is a pointer. So essentially, this is a array of pointers, and each of the pointer is pointing to the reaction object. Okay, you have a question there? I thought you say something, sorry. Do you have a question? Okay, sorry. All right, so let's continue. If you have a question, just let me know, okay? So we have an array of pointer, and then this is array of pointer, and then again, I have a reactions. Reactions itself is a pointer. So essentially, reactions is defined as a pointer to an array of pointer. So it's a little bit complicated there, but I want to show you what it looks like in a slide. I described that in one of the slides, I believe, at the end. Yeah. So this is essentially what I talk about. It looks pretty complicated, but this is what we have. So you can see that, oh, I have 1 second. Okay, so this is the code we just look at is reactions. That means the type of the element. So essentially we have a vector. So this vector, it has, each of this has a bunch of elements, just like array. But each of the element, the red triangle here, is actually a pointer to a reaction object. All right, so that's this level. And then we have in the comments, we have a variable called reaction. Itself is a pointer, is pointing to this particular vector. So that's the code. This is the code I actually showed you earlier, but this is the picture representation of the whole data structure. Right. So just let you know that in order to manipulate a vector in C++, so vector in C++ is an advanced way of doing array. Of course, you can still use the traditional array index to access a vector. That's still doable. But usually I don't do that. I use the function, the interface function that's actually provided by vector. And usually I just use especially when I want to insert an element into an array. I actually don't try to manipulate the index because I need to figure out where's the end of the array and I need to do memory allocation. They actually took care of that for vector. Vector, you don't need to worry about allocating the memory. It will automatically take care for you. And the best thing is I don't need to worry about the index for most of the case. What I did, I just used pushback. I just basically push the things go in, and then I can pop the element out. It's almost like a stack or queue kind of situation. You can think about it's an array, but you can use a different interface to do that. So I will show you how you use pushback. So just basically push an element from the back into the vector. And then you can have a new pointer, it's pointing to another reaction. So this is essentially before the pushback, you have a pointer to a reaction, you just put it in, and just like everybody else is like that. Okay, so that's what we have for this part of the code. Any question? All right. All right, so that is what we call the comment has this line is probably the most complicated line in this code. It's just how do you represent an array of a reaction that's actually related to a communication. I do want to say a little bit about the programming about array at this moment. So most of the time when we access an array, we're thinking about, okay, I'm going to insert this element in which position, insert this particular element in another position. But in today, a lot of application, instead of worry about where this array need to be, where this element need to be placed in which position of the array, a more commonly used paradigm is try to append the new element into an existing array. So for example, if you want to make a social media, you want to add a new comment. I'm not usually trying to insert that comment to the middle of a conversation. Usually the new comment will be appended to the end. Or you want to introduce a new reaction, you want to click a like, or you want to click. So that is usually goes to the end. So it's essentially the world is being linearized by the timestamp when you actually get into that. So essentially, that's why the vector is so useful in this case is I just keep pushback. Whenever you have something in, I just push back. And then you actually build up that data structure contain maybe millions of elements for that particular vector. And you don't worry about memory because the C++ language will help you to take care of the memory. That's much better than you try to predetermine how many elements you want for that array. Because remember, when you have array, you usually do a huge malloc and you start to do something. And this is a huge improvement for C++ in this perspective, is that I just specify an array looks like this. It's open-ended. In fact, you can put one element there, you can put 1 million element there, doesn't matter. So that language already took care of that. Okay, so that's important for you to know, is that in the C++ world, try to use things like a map or a vector as much as you can. But the other one, which I highly recommend for you to do, which is homework 6, you will learn that, is called map. It's another STD map, which is help you to do a lot of key value pair kind of array. Okay, so now we have this reaction. So now what I want to do is I want to do a JDump, because I want to convert this one into a JSON representation, which has all the reaction that's being contained. Okay, so now let's actually look at, go to comment.h. So any question about comment.h before I move to comment.cpp? So just the remaining part is essentially just a JDump. Okay, this is you can see that this is a reaction. This is constructor for this comment object, and then there is a DUMJ, and then there is a JDump. So right now, JDump, I actually commented out. Okay, so you just need to worry about DUMJ. Okay. Okay, this is the code that you actually receive for comment.cpp. So the constructor is already provided for you. You don't need to do anything. But this is a function you need to implement, which is DUMJ. And currently, it just returns the value new, means that it's not returning you anything. If you run the program, by the way, if you run the program, and it will just tell you that it's null, because why? Because DUMJ is not implement, so that's why what you get. But what you should have running, if you run the program, let me just show you the output, and I will show you the code. If you actually run the program, it will be looks like this. Let me actually show you. This one already have some debugging message, because last time when I did this demo, I'm actually telling students that how things work, so interactively. So that's why I add all this extra code. But let me actually show you what the output should looks like without those things. Okay, the code will, the things will looks like this. For example, this is a comment that's actually have a, this is comment has a reaction time, has avatar, has a test message for homework 4 part 3. That was when I released it last year. And then you will see that you have an array of reactions being generated. This is the part I want to show you. You can see that this is now has a reactions, which is an array of pointer, but instead I'm actually using this JSON representation to include 2 reactions. So this is the first reaction, has a creation time, has a from, and a person object, and has a tub. One is love, one is happy in this particular case, Trinity and Neil. Yes, please. This is homework 5, sorry. So I said homework 4 part 3. This was because last year, this was homework 4 part 3. So, but this year I actually re-encoded to be. This has nothing to do with homework 4 actually. Homework 4 is about multiple inheritance and the virtual inheritance. Yeah, sure. Sure, go ahead. Sure, you can do anything you want with math. Yeah, thank you. Yeah, you're pretty advanced. You already start using math. Yeah. So I guess you learn by yourself about how math should work, right? No, map is a nice tool when you have a search, but not search by index. You search by a key, and which is really useful to use map. Yeah. Okay. And thank you for telling me that he has a question. That's good. That's good. That's a good collaboration. Good teamwork. Okay. All right. So we have, so you can see that this is a representation. By the way I represent, you see this looks nicer, right? This looks nicer than, remember I showed you a slide looks like this. This looks really packed, but unreadable. If I show you a JSON looks like this. This is really hard for you to read, very hard to parse. So in JSON, when you print something, you call toStyle string. So you probably heard me using this function. Whenever you see toStyle string, is that the JSON will print out the JSON in this kind of style. So this is called toStyle string. Looks like it actually separates each bracket or each curly bracket of the element. So it actually, you can show the structure about a JSON object within the other JSON object. Okay, so that is what we want to generate. So now let's take a look at the code, how I actually get that part to be taken care of. I'm going to use Emacs comment. I just want to show you that piece of code. 1 second. Hold on 1 second. Give me a. Okay, I'm going to do this. I thought I have a piece of code that I can do this without revealing my secret, but anyway. Anyway, I'm going to show you this a little bit. I just want to come this part. Yeah. So you can see that what I did is I actually still go through that array. This is the array that I go through every single reaction. This line of code is I is equal to 0, I is smaller than, reaction is a vector. So how do I know how many element a vector has? Has a size. So there's a function called size used with a vector that you can actually access to the size of the array. And then what you do is when you iterate, you see that I use, because this reaction is what? It's a pointer. So I have to add a star here, that's the content, and then put the index I. So by doing this, I'm actually getting the pointer to that particular reaction that I want to get. So if you compare this slide, this is my favorite slide, by the way, when I draw this kind of thing. Essentially, what I'm doing is the size is for me to figure out how many elements in this array. And each of them, when I retrieve, is a pointer to the reaction. And so when I come back to the code, essentially, this is going to be a pointer to the reaction, and the reaction has a DUMJ. So I just call this DUMJ. And what's the return value of the DUMJ? Is actually a JSON value, which is a JSON object. So essentially, this one gives me a pointer called JSON JV pointer, which is actually give me as a what do I call that? Is a JSON object pointer. And then what I do is that now you can see this is the trick. I have something called JSON C reactions. So JSON C reactions is an array of JSON objects. So the reaction is a C++ object, but I have a JSON side. on the JSON side, I also have an array object. That's actually called JSON reaction C. And then JSON reactions. And then I just put the index, the same index, I just assign that value into that. And after that, I actually have that element being inserted into that. So this is the part which you actually starting to see the conversion between the C++ array into the JSON array. So this is actually the most important instructional objectives I want you to learn is that how do you actually manipulate array with two different worlds? One is C++ world, one is JSON world. So let me actually go up a little bit and tell you how I define JSON C reaction. So JSON C reaction is being defined here. You can see that JSON C reactions, JSON C reaction itself is an JSON object. But in JSON object, I don't have to say that JSON object is an array or not. I don't have to say that because JSON object could be an array, could be basic type, could be a JSON object itself. So until I actually do this code, when I do this, I essentially tell the system I'm treating this as a JSON object. So by doing this, JSON C array, I actually put this object into that, so I have that. So you can imagine that JSON C reactions in this case, at the end will be represent this part of information. Let me just show you over here. Sorry, let me go to the nice output I generate. So each of this is a one reaction JDUM. But the JSON C reaction is actually represent this part because it's an array. So this is an array. So I'm actually putting two elements into that in between that bracket. That's an array. That's how you define. That's JSON C. Okay, so now I'm going to show you a bit more complicated from now on because this part is the most important part for you to understand. That's why I'm kind of over time, just 2 minutes. So you can see that after I put that into the curly bracket, you see I have JSON C reaction array. What is a JSON C reaction array? It is still a JSON object. So in JSON, doesn't matter it's an array or whatever, you actually put that as a JSON value object. But here I did is I put the data part. The data part is equal to JSON C reaction. So whatever that bracket I generate with the JSON C reaction now is become part of the data. So now if you remember, I showed you earlier here, you can see that's why this is JSON C reaction. And now I'm actually putting into the data. So essentially this part is a JSON C reaction. So the middle part of the bracket and the curly bracket, I hope you can match this one with a video when you see that later. So you can see that this is part of the code is really how do you handle this array. That's my, and the last part, sorry, the last part, this part I'm actually putting the data, this part I'm just putting the count. I'm putting the count part, data part, and count part. And finally, I put the whole thing into reactions. So now let's actually look at the code, look at this part again. You see this part? This part, this is a reaction, one single reaction. This is JSON reaction C. This, from here to here, this is JSON reactions array. And then the final one, I'm assigning that to reaction. I actually complete just this whole part here. Okay, so you can see I grow from this part, the inner part. Let me do this again. I grow from this inner part to this JSON array representation, which is a bracket. And then I assign to the data, I also assign to the count. And then I put everything into an object. This is called JSON C Array. And then I finally go to the reaction itself. That's why I have a 3 assignment. You need to be very careful, understand what's happening. This part is just construct for JSON C reactions. So JSON C reactions data part, I'm going to use JSON C reaction. And the count part, I'm going to use the array size. But at the end, after I finish this, I'm actually putting the whole thing, JSON C array, putting into reactions. So that's the way that's part how you handle the JSON side of the array objects or whatever JSON value object. You can think about that. If I actually show you a piece of code, which is how do you actually handle this one? Where's my? If I give you a piece of code, I said, well, can you actually handle this? As a C programmer, it's not that easy. It's not that easy because the structure is fairly complicated. It has different parts. It actually has recursion in terms of information representation from one side to the other. But the JSON value, the library, the object-oriented interface, which is actually defined in the JSON CPP library, it's actually very elegant. You just basically go through that iteration using that style. You can see that I show you a piece of code. It's probably about totally to handle this part of the object. It's probably only about 12 or 13 lines of code. And you just need to know how to manipulate the JSON object using that style. It's very different from C++. But once you know how C++ handle this, you know how JSON handle this. With this two world, then you pretty much can handle pretty much all the information you can swallow today in the realistic world. Okay. All right, I'm going to stop here, and because I'm really sorry to use that extra time, but I will just walk back to my office because the office hour will start immediately.